we now come to the third section of this particular exam paper, the Level 2 Maths Legacy Functional Skills. And it's again sets up on a specific topic. So again, for demonstration, we have set topics to run through in the sections, which again may be related to real life. This is all about organising a run. So Zara is the manager of a fitness club. She organises a run around the park. She needs to plan a route for the run. Zara has this map of the park. Diagram not accurately drawn. So we can see we have a meeting point, and then we have various points like points F, point G, point A, point C, point D, point E, with all between them. So for example, meeting point F is 330 metres, F to E is 1,260 metres, and so on and so forth. And we have a little special bit, which is the lakeside path between points G and C. Again, just take a few moments again, put it on pause, look at the question if you want. Zara wants the route of the run to start and end at the meeting point, along the full length of the lakeside path, go through point A, and have a total distance of between 4 and 4.5 miles. Zara knows that 5 miles is 8 kilometres. And a route for Zara show the total distance of the route. Okay. So we now need to plot a route. And the way I've approached this, I've looked at it like this. Meeting point to F, follow me through, is 330 metres. Point F to point E, 1,260 metres. Point E to point D, 920 metres. D to C, 430 metres. C to G, because this is where we now have to incorporate our Lakeland part, is C to G again, is 970 metres. G to C, 850 metres. C to B, 520 metres. B to A, 790 metres. A to meeting point, 350 metres. And you do need to write these all out. This was a real question and a real test. It was a real question once in a real test because these are all past questions. You will need to write all of these out because it's showing that you're working out all the distances that you need and you're planning your answers around. We then simply add all these distances together, which is 6,420 metres. Remember, 1,000 metres equals a kilometre, so that's 6.420 kilometres. Right, because we have a 0 there, 4.2, 6.42, we can just call it 6.42 kilometres and be done with it. But we just want to double check we are sort of getting near our 4 miles now. Probably if you look at it, estimating, you're going to get a good idea that you're actually going to be near that anyway. But let's follow the equation, all the things that they've given us. So we're looking at 6.42 kilometres. We multiply that by 5 miles. I'll get our conversion. And we divide it by 8, which is 4.0125 miles. So we are just over our 4 mile limit, which is acceptable for this answer and is suitable for the amount of running that needs to be done for this particular theoretical question. Again, what I suggest is put this on pause, have a break for my voice, spend a little bit of time, valuation, reflection, and just digest this question quietly in your own time. Before we tackle the next question, let's just have a reminder of the grey cells. Just remember area, length times width. Have a 2 after it, which means squared. 6 times 3, 18 centimeters squared. If we're looking at this particular rectangle here, as opposed to volume, which is length times width times height, area is just length times width. So we've had a brief recap. Let's proceed to the next question. So, advertising in newspapers is charged by area. Zara wants to advertise the run in a newspaper. She'll use a rectangular picture, 105 millimeters by 148 millimeters. To use the picture in the newspaper, she needs to reduce the size. she'll use the scale factor of 0.8 to reduce the length of work out the area of the picture that appears in the newspaper. Okay, not as daunting as it looks. You might think it is, but it's not. Essentially what we need to do is, for example, take firstly our 105 millimeters. When we get something like a scale, we times it by the factor that we've been given, which in this case is 0.8. So, following that through, all we do is 105 millimeters times 0.8 gives us 84 millimeters. 148 millimeters times 0.8, which is our factor, gives us 118.4 millimeters. This is the scale of the rectangle we're going to use. So this literally becomes 84 millimeters times 118.4 millimeters gives us an area of 9,945.6 millimeters squared. That answer is 945.6 millimeters squared. Again, if you're not sure, play this back, spend a little bit of time, then I'm recording on pause, and have a look quietly without me speaking, and just reflect on the question. Time now for question 9. Zara needs to buy t-shirts to sell to people at the run. She finds this offer for t-shirts: £4.79 per t-shirt, add a logo, £2.90 per t-shirt, buy more than 100 t-shirts, each with a logo, and get 15% off the total price. Zara wants to buy 130 t-shirts. Each t-shirt will have a logo on it. So, how much will Zara pay in total for 130 t-shirts with the logo? Okay, so firstly we start off. We need to add up t-shirt price and logo per t-shirt. Simply £4.79 plus £2.90, £7.69 is the price of one shirt. Now, we need that figure by 130 to find out what the price will be for 130 shirts. So that is £7.69 times 130 gives us a grand total of £999.70. Now, there are different ways you can work percentages out at this point. You have your own way, and it actually gives you the answer at the bottom of £849.75. And that method works for you. Do not let me try and influence you and change your way of doing things. Right? However, what I've done here is just the methods that I know that could actually get you to write the answer. Some are a bit more long-winded, which some of us are more comfortable with. Others are a little bit shorter. But again, you have your own personal preferences. My way actually with doing it would be the long-winded way, which is £999.70 divided by 100 times 15% gives you £149 and 95.5 pence. Okay. So we look at that. It's 900. So we now do 999.70. Take 149.95.5 equals 849.74.5 pence. Remember what we said about the 5 at the end, decimal points. Up to £849.75. Other people might use to find a percentage is 999 times 0.7. Sorry, let me start that again. £999.70 times 0.15. So what they do is they put a naught and a point in front of the percentage. It gives you the same 149.95.5. And again, same method as above. Take your £999.70 from your 149.95.5 equals 74.5 pence, which you round up 849.75. Another way is 100 minus 15, which gives you 85. You then do your 0.85 times £999.70 again, which gives 849.74.5, which is 849.75. That gives you the answer essentially straight away. But regardless of the method, as long as you get to the final answer, which is £149.75, you work whatever method is suitable and best. Again, if you want to learn a new method, spend a few moments, but it's on pause, have a break my voice, and have a look through. Let examples given. We have come to the final question of this paper. Here we go. Zara wants to record some information about the people who take part in the run. She wants to know their gender, their age 16 to 30 over 30, how they heard about the run, newspaper, internet, friends. Design a data collection sheet for Zara. Okay. Initial thoughts, you're thinking sheet, you're thinking this is going to be complicated. Well, actually, it's designing a table, and that's what it is. So, something like this potentially is going to be in table when you get it in the question. So again, my famous RGFQ, there are no figures here. It's just about designing something that's practical and going to work. And what we have here is a sample below. We have columns, gender, male, female, top, male and female. That then breaks down to age, so we can see 16, 30 for male, 30 plus, and then same for female. Then how did you hear? Well, then we can then probably, however they want to work it, then fill it in accordingly for newspaper and friends. Perhaps I can do a tally chart, we don't know. All we're doing is designing a table. And this is the simplest, most practical version that I can find that would actually do. And the reason I've got brackets in is because, for example, male could be represented by M, female by F, newspaper by N, internet by I, and so on and so forth. But actually, this is quite good. Sometimes these at the end have a nice little sting in the tail for you, really difficult questions to finish you off. This one, they've actually gone the complete reverse and given you a very simple one, which you'll probably overthink because you've had a few complicated questions beforehand. So, everybody, that's this paper dealt with. What you might want to do, again, is just quietly go over this in your own time now. Put it onto pause, go through, not have my voice on top. Sit back and do some reflection. Perhaps take some photographs of it. So if you can't, or screen dumps if you're using your phone or your computer, or screenshots, I should say, that sounds better. So if you have spare time, you can look at them that way, and you've got peace and quiet. Okay. All the best, and I hope you have found what's been presented in front of you here to you useful.